All right, everyone, so here we are for part 4, section 17.2. Hopefully the last section should be the last video for this section. We're going to start with taking a look at second order partial derivatives. So if you think back to your 212, your business calc 1, if you could take a derivative, you could take a second derivative, you could take a third derivative, fourth derivative, you could just infinitely take derivatives. Same thing with partial derivatives. If you can take a first partial, you can take a second partial. It's just more complicated because there are 4 different orders that we can choose for the process. What I mean by that is we could take an x and then another x. We could take a y and then another y. We could take an x and then take a y. Or we could take a y and then take an x. So if you have a 2-variable function, z equals f of x, y, then this table right here represents all the partial derivatives you could take. So working from the left to the right, this is take the partial with respect to x of the partial with respect to x. Look at this notation right here, and I'm going to zoom in on that. Do you see how we use the exponent 2 to show that we took a partial derivative twice, and then the exponent 2 in the denominator to show that it was with respect to x twice? We could also use this notation where we just use the subscript x, y, y, with respect to y, with respect to y again. Take a look at this notation, okay? This means that the first time we took the derivative was x, and the second time was y. So we're reading from left to right here. First partial with respect to x, and then the second partial with respect to y. And that is not the same as this order right here. This says first time you do y, and then the second time you do x. Reading from left to right. First time y, second time x. So there are 4 second order partial derivatives. But actually that's a lie, because it turns out that these two end up being exactly the same no matter what you do, right? So whether the order is x and then y or y and then x, the final result ends up being exactly the same. So then we get into this sticky situation where if it says to find all of them, you really have to find 4, but you only have to do 3 things because you'll just label one of them twice. Right, so let's go ahead and see if we can make this happen. I need to find all the second order partial derivatives, which means I need to take a bunch of first partials and then take seconds. So first things first partials. I'm going to find f sub x first. Now I'm going to get a little lazy with my notation here. It's an acceptable level of lazy. I'm just going to say f sub x. I've named the function and I've told you what partial I'm taking, so I've got enough information down. I'm just going to leave out the definition of the variables being x, y. First term, first partial with respect to x, is going to give me an 8x y squared. The second term is going to give me a negative 32x. And the third term goes away because there's no x in it, right? I also need the first partial with respect to y. First partial with respect to y, the first term is going to be 8x squared y. Second term, there's no y in it, so it goes away. And the third term is just a 4. So there's my first partial x, my first partial y. Now I'll start working on my second partials. Okay? F sub x, x. That means go back to the purple one and take the derivative with respect to x again. First term with respect to x is going to give me 8y squared, and the second term would be 32. And there's my second partial xx. My second partial order partial derivative with respect to x both times. Okay? But what about f sub xy? Okay, so f sub xy means go back and find the purple one, for f sub x, and then take the derivative of that one with respect to y. So the first term with respect to y would be 16xy, and the second term with respect to y would be 0 because there's no y in that second term. Moving right along, how about f sub y, y? Well, that means go find the first partial with respect to y and take its derivative with respect to y again. So go back to the gray one and take the derivative of that with respect to y. First term with respect to y is going to be 8x squared. Second term with respect to y is 0, so there's my second order partial derivative with respect to y both times. And then, because I'm just that guy, I'm going to find f sub yx. Now, according to the rules, that should be the same as the blue one above it. But what I'll do is I'll just check it to be certain. F sub yx means go find the first partial with respect to y, f sub y, and then take its derivative with respect to x. So that's this one up here. First term with respect to x is going to be 16xy. Second term with respect to x is 0, because it's just a 4. And you see how these two ended up being the same? That's because second order partial derivative xy is the same as second order partial derivative yx. It makes me happy, because those two are the same, so I don't really need to do both of them. I just did them both just to check to make sure. Okay, another example, and then we'll be done with section 17.2 finally. Okay. Find all the second partials. Let's go ahead and get started on this. I'm going to rewrite this just so it stands out a little better for me. It's negative 6x times e to the y squared. I like that better. All right, so first orders, z sub x. Two terms. This is the first term. That's the second term. They're being multiplied together. Actually, it's one term, but it's two things being multiplied together. So let's see. Wow, that's just going to be negative 6e to the y squared, right? Yeah, that's not too bad. All right. How about z sub y? Let's see, that's going to be negative 6x times e to the y squared times 2y. So I'll clean that up. That's going to be negative 12xy e to the y squared. And there's my z sub y. Let's take a look at some second partials. Z sub xx. Z sub xx is going to be the second partial derivative with respect to x. So it's back to this guy, then take the derivative with respect to x. But there's no x's there, so it's just going to be 0. I like that. I like that a lot. Okay. How about z sub xy? Let's see, that means again go back to that one, but now take the with respect to y. So that's going to be negative 6 times e to the y squared times 2y. We're cleaning that up, negative 12 e to the y squared. I'm okay with these. That's okay so far. So there's my z sub xy. All right. How about z sub yy? Uh-oh. This is going to get ugly, because look at this. Oh, man. I don't know if you're seeing what I'm seeing. It's something we haven't dealt with yet. So let's go ahead and I'm just going to copy it down here to begin with. The first partial with respect to y was negative 12xy times e to the y squared. I don't know if you're seeing what I'm seeing, but this is going to take a little bit of work because I think we've got a product rule sitting here, don't we? Don't we have a product rule where here's one thing and then here's the other thing and they're being multiplied together and we have to take a derivative? Do you remember the product rule? The product rule said that if you're taking the derivative with respect to x of u times v, that was u prime v plus v prime u. And since we're taking partials when we're doing those two pieces, we just need to do partial derivatives. Okay, so then z sub y is going to be, let's see, z sub y, it's going to be the derivative of the first one. So we'll call this one the u, and we'll call that one the v, right? So it'll be u prime, so with respect to y, that's negative 12x times e to the y squared, plus, and then I have to do u times v prime, so negative 12xy times derivative e to the y squared, that's going to be e to the y squared times 2y. Okay, and now I'll clean that up. So I've got negative 12x e to the y squared minus 24xy squared e to the y squared. And there's my z sub yy. Now, do I need to do z sub yx? I mean, I technically already have it right here at xy, but I'll do it just in case. So I'm going back to here and I'm taking the derivative of that with respect to x. Negative 12y e to the y squared. Uh-oh. Oh, I got a typo up here. There's a y right there that I forgot to bring down. So let's go ahead and fix that. It's a good thing I did both of them. I caught my mistake. There you go. Now they match. I feel better about that. All right. So as you can see, it's easy to make mistakes with these. Take your time, work them out. That brings us to the end of section 17.2. In section 17.3, we're going to take a look at maxes and mins, maximas and minimas, which will be the place or the application for these second partial derivatives. We'll be using those to find those maxes and mins. So I'll see you all back here for section 17.3.